My esteemed viewers, in this tutorial, the continuation of problem solving using C, we discuss about or we present about the iterative constructs or looping constructs provided by C. Whenever a statement or a group of statements are to be repeatedly executed in a program, iterative construct is a must. The concept of looping is nothing but the control getting executed several times again and again, and this is shown in the flowchart segment over here. And in this flowchart, the control comes over here, it does all the actions whatever that is indicated, it once again goes back, it repeats the action. So therefore the action is repeated over and over again and it never stops as far as this flowchart is concerned. Since the loop in this figure never stops, it is the computer version of the perpetual motion machine. The action or the actions will be repeated forever. We definitely do not want this to happen. We want our loop to end when the work is done. To make sure that it ends at the requisite point of time, we must have a condition that controls the loop. In other words, we must design the loop so that before and after each iteration, it checks to see if the task is done. If it is not done, the loop repeats one more time, and if the task is done, the loop terminates. This test is known as loop control expression. Collectively, the constructs provided by C or any other language, as a matter of fact, is also called semantically the loop control constructs. That is, meaning wise, they are also called as loop control constructs. So in order to develop a loop, whatever the version the looping construct be and whatever the language be, loop should be provided in order to operate with the loop, in order to execute the loop, in order to press loops into action. We need what is called as a counter. My respected viewers, this counter is something like the counter that is available in a typical petrol bunk. In petrol bunk, if we order for 3 liters of petrol, the person who is standing beside the counter will set it to 0. Then first liter is poured into our our vehicle, and it will check. It is not equal to 3. We have ordered for 3 liters. It will pour the second liter. 2 liters. 2 liters are over. Once again it will question whether the third liter is poured or not. No, it has not poured. Once again it will pour, or it will let go the third, the liter, the 3 liters. When 3 liters are over, it will automatically stop, and the counter will once again come back to 1, or comes once again to 0. This is what exactly the counters mean. And here in a loop control parlance, it is called as loop index or loop control. It is typically integer, and this loop control works something like this: j equal to j plus 1. That is, one iteration is added. Or it can be told something like this: j plus equal to 1. Succinctly, j equal to j plus 1 can be written as j plus equal to 1, or k equal to k minus 1. This is the loop in the ascending order. The loop is going and loop is descending. It is coming down, maybe from a higher order to lower order, or higher value to lower value. Here it is lower value to higher value. Anyway, C allows increments and decrements to be shortened even further using plus plus or minus minus operators. Plus plus will add 1 to its operand, and minus minus will subtract 1 from its operand. It's a succinct way, very simple way or crisp way of adding 1 to the variable, to the counter, and this is subtracting 1 from the counter. This is in the increasing order of the loop, and this is in the decreasing order of the loop. That is the thing that is conveyed by this. And the counters or the variables, counter variables or loop indexes will look something like this. Okay, this is postfix increment, and this is postfix decrement. This is prefix increment, this is prefix decrement, and this is postfix increment, and this is postfix decrement, and all of them mean one and the same. The meaning is k equal to k plus 1, k equal to k minus 1, k equal to k plus 1. When they work alone, they are one and the same, but when they appear aloof, they are one and the same. When they appear in an expressions, they will have some kind of a side effects. We will see that as to how it can be used. So we can take this example, k equal to 1, k is set to 1, printf, k is percentage d slash n, we have written plus plus k over here. Since we have written plus plus k over here, it will be k will get 2 and 2 will be printed, and k is now will be 2. Okay, in the memory of k it will be 2, and here exactly 2 will be printed because it is post increment. We will just elucidate it further, okay, and we will look into example number 2, j equal to 1, j is percentage d, j plus plus. Here what computer fetches is j value, because j equal to j plus 1. Okay, later on, so first of all it is as good as telling j equal to j plus 1, but what this percentage d fetches is the value of the j. Therefore it will print 1 over here, and it will print, and by the time the control leaves this particular statement, j would have become 2, and here in this statement j will be printed as 2. And this can be better understood with this example, with this explanation. X equal to a plus plus will only mean x equal to a plus 1. Therefore what x gets is a, immediately what it fetches is a, and what happens in the memory of a is a plus 1. And here in the same token, if we write x equal to plus plus a, this is as good as writing expression something like this, x equal to a plus 1 equal to a. Therefore what x gets in the immediate instance is a plus 1. Therefore 1 added to a. Therefore if a equal to 1, if a equal to 1, it will print 2, and here also in the memory called a, it will be 2. Okay, in the memory also a would have become 2. And a plus plus, a, same explanation holds good even for minus minus, or a minus minus, and minus minus a. Okay, a minus minus is post decrement, and minus minus a is prefix or pre decrement. Okay, and we will just understand as to how the meaning of this a plus plus and plus plus a will change whenever they appear in a big expression. When they are aloof, I told you in the beginning itself, when they are aloof, it's one and the same. A plus plus is same as plus plus a. Okay, whenever they come in an expression, the value what goes to x is different when compared to what goes to x over here. Okay, that is a very important thing that we should remember. And we will see how exactly the evaluation of an expression involving postfix and prefix will really happen. Let us assume a equal to 3, b equal to 4, and c equal to 5, and we have a big expression something like this, arithmetic expression, minus minus a into 3 plus b within the brackets divided by 2 minus c plus plus into b. Okay, anyway, as per the Badmas rule, this will be having higher precedence, therefore this will be evaluated. It becomes 3 plus 4, it becomes 7, and this will be retained as it is. In the second step, this will be executed because it has a higher precedence when compared to minus minus a. This is the 15th precedence, and this is the 16th precedence as far as the order of precedence is concerned, the order in which the expressions are evaluated. Okay, so c plus plus will become 5, okay, and b will be retained as it is, and this remains the same, and minus minus a. Now what happens is minus minus a will be executed, and it will become 2 because a was 3 and minus minus a would only mean 2. So 2 into 7 divided by 2 minus 5 into b. Anyway, this division and multiplication have the same precedence. When the compiler looks like this, okay, from left to right, 2 into 7 will happen, so it will become 14 divided by 2 minus 5 into b, and 14 divided by 2, and anyway associativity is like this, therefore 14 by 2 is 7 minus 5 into b. Okay, 7 minus b is 4, 7 minus 20, it gets us 13, minus 13. Therefore we should be using, we should use very carefully whenever this is pre-increment or pre-decrement, post-increment or post-decrements are involved in a very big arithmetic statement or big expression. Now in this tutorial we will just elaborately discuss the for loop, since the simplest possible loop provided by C. C has other two types of loop constructs, that is namely while loop and do while loop. We will discuss separately those, how exactly those control constructs will work. For time being, in this tutorial we will discuss threadbare as to how the for loop works. Okay, the general syntax of for loop looks like this: for, open the what is that, round bracket, parenthesis, expression. Actually it's better we write expression, okay, expression 1, okay, expression 2 and expression 3. Expression 1 is initialization expression. The loop index will be initialized over here. Expression 2 is all about testing the condition or conditional testing. Expression 3 is usually either incrementation or decrementation. I repeat, expression 1 is the initialization and this is the test expression whether we have reached the end, and expression 3 is either incrementation or decrementation depending on the problem. Let us not be discouraged. We should not be discouraged by the for statements to be appearing little complicated. It is indeed the best way to write for loops among the other two loops. When compared to other two loops, this will come very handy because all the related expressions are just attached in the single line. So every control will come in the single line. Therefore, it is very easy to remember and very easy to use this in a programming environment wherever iterations have to happen. But the condition is where to start and where to end should be well known, or should be known beforehand. Okay, before we think of using for loop. Okay, there are 3 examples that are being given. Okay, we will go through scientific examples or chosen examples, or whatever we call as benchmark examples, in order to reinforce our understanding as far as how exactly for loop works. Okay, for k equal to 0, this is initialization expression. Okay, k is initialized to 0, k is an integer, of course. K less than or equal to 10, k plus plus. Okay, this loop will execute from 0, 0 to 10. 0 is included, 10 is also included. Therefore, this for loop literally executes exactly 11 number of times. Okay, 0, 1, 2, 3 up to 10. Okay, so 11 times the statement or statements are executed, whatever that are written. Whenever the number of statements are more than 1, you need to include them in a block, otherwise only blocks are not required. If it were to be only one statement which works under a for loop, there is no question of these flower braces and there is no question of making a block. By default, it will be considered as the for loop block. And here this for loop executes in a descending order from n-1 down to 0. This is 0 up to 10. This is down to 0, n-1 down to 0, and k will be decremented in every iteration. Okay, and here this is n down to 1. Okay, and this is also iterative construct, which goes from a higher value to a lower value. This is also from a higher value to a lower value. This is from lower value to a higher value. Okay, whether we should use this kind of for loops or this kind of for loop where indices are controlled like this depends upon the problem. Therefore, it is problem specific. When we go through different problems, we will really understand as to when we should go some kind of an ascending iteration, some kind of a descending iteration. Yeah, we will move with the problems. Okay, add series 1 plus 3 plus 5 up to n. Okay, and we need to read n number of terms. and the term should be 1 plus 3 plus, that is odd series. Let us call this as an odd series. Anyway, we will just start like this, because we have already understood as to how C is to be written and what are the statements that are to be written. Okay, include the files, necessary files, and declare the variables. Okay, and clear the screen, because whenever this program is repeatedly executed, the screen may look clumsy. Therefore every execution should have a clear screen. Therefore clear screen is written over here, and this is written in conio.h. therefore we need to include this. Anyway, this has been told several times in our previous tutorials, therefore let me not repeat it again and again. So we need these many variables: I to run the for loop, n to take account of number of terms that we need to generate or we need to add, sum equal to 0. This is called as an accumulator. This is a special kind of a variable which accumulates the sum value. Initially it is set to 0, and as and when a term is added, it will go to sum. Okay, this is something like a box, it accrues the sum value. Okay, iteration by iteration. There is a question that is posed for the user: how many terms? He will enter say 10, he may enter say 20. Okay, that will go over here, and n will store, okay, the last term up to which summing is to be done. So I is set to 1 because the series starts with 1. I is less than or equal to n, it should go up to n number of terms. I equal to I plus 2. In every cycle, I is to be added with 2. So in the first cycle, I will be equal to 1. In the second cycle, I will be equal to 3. In the third cycle, I will be equal to 5. Therefore, we are generating some kind of an odd series, and here we are summing it up. Sum equal to sum plus I. Okay. So in the first cycle, so the control will literally move like this. We will trace the control as to, okay, in order to understand clearly. So control will come over here like this from the top, and I will be initialized to 1. Then the test expression will be evaluated. Is I less than n? Yes, I is less than n because I is 1. Then this statement is executed. Okay, when the control looks at the semicolon, once again it goes back over here. I will be incremented to I plus 2, it will become 3. Once again it will be tested. Yes, it is 3, which will be definitely less than n. Therefore once again it is executed. So the cycling happens something like this: 1, okay, 1, 2, okay, this is the second thing that will happen, 3, 4, okay, once again it will go like this. So this is the cycle that happens like this, and like this. When I crosses n, then control will go out of the loop. When I crosses n value, okay, the control will come over here. The control will come over here and it will print sum of the series equal to sum. Okay, the sum will have been accrued in the variable called sum, and sum will be printed at the place where percentage d is indicated. So we will further move, and this for loop is explained by means of a flow chart. You can under expression 1, this is initialization expression, and it will come to expression 2 to check whether the initialized value is correct or not. If it is true, statements are executed, and expression 3 will take place, and expression 3 either incrementation and decrementation will happen. It will go over here again. Once again testing will be done if it is true, so it will be cycling like this. Whenever it becomes false, okay, whenever it becomes false over here, the control will come like this and it will join the mainstream. Okay, it will join the mainstream, it will go along with the mainstream, it's over here. Okay, it will go and join. And for example, if we happen to print the value of I over here, what we get is 2 more than n. Okay, if you have called this number of terms equal to 10, what we get here is 10 plus 2. 11 plus 2, 10 plus 2, 9 plus 2 exactly, because it will stop at 9. Okay, because we are printing odd series. Okay, stop at 9. So 9 plus 2, it is 11. 11 will be printed. The I value will have been 11. Therefore, since I became 11, it has the control has left this particular for loop. Okay, for loop block. Okay, we have understood as to how for loop works. Okay, anyway, generally for loop is to be is to be implemented, or for loop is to be considered when the programmer knows as to when to start the looping construct or when to start the iteration, what is the initial value of the iteration and what is the last value or end value of the iteration. If the terminals of this iteration is known beforehand, then for loop is the candidate, because these things are to be known very clearly, because at times we will be confused as to which kind of a construct is to be used when we are in a programming environment, because traditionally C provides three kinds of looping constructs: the while loop, do while loop, apart from for loop. So we will go through the second example. Second example is all about to add 1 square minus 2 square plus 3 square minus 4 square plus or minus n square. This is the thing. Anyway, it is similar to this one only. Okay, but I is to be square. The loop index will be critically used in order to generate this particular series as well as the sum of the series. Okay, so whenever the loop index is squared, whether it is minus, it will become positive again. Therefore, somehow we have to achieve this alternative positive signs and minus signs, positive sign and negative signs. Because when you induct a number with a negative sign, when you square it, it will automatically become positive. Therefore, we cannot achieve this kind of a summing. Therefore, let us see as to how this can be tackled. Okay, here we have declared integer I. This is a loop index. This is to take from the user as to how many terms he or she wants. Sum equal to 0. This is an accumulator for possible accumulation of the sum value. CO is the coefficient. We use another variable called as coefficient. This coefficient will be wedded with all these values so that we can achieve alternative positive sign and negative sign in the series. Okay, clear screen please. See, declaring the variables and putting the clear screen is called as housekeeping. Okay, from here till here, the processes whatever we did is called as housekeeping in a programming, okay, parlance. This is called as housekeeping. Okay, we will be knowledgeable about this. Okay, let us remember this. Okay, enter the number of terms. Enter the number of terms is the question. Then the user will enter number of terms. Coefficient is set to 1 plus 1 plus 1. I equal to 1 because the series starts from 1. I equal to 1. Okay, I is set to 1. I is less than or equal to n because it has to go up to the nth term. I plus plus. Now sum equal to sum plus coefficient into brackets I into I. So in the first cycle, sum equal to 0, sum was set to 0, sum plus coefficient is 1, 1 into 1, 1 into 1 into 1. So this becomes 1 square. Now before the control leaves this for loop block, CO will be wedded with minus sign. So CO will become minus CO, that is earlier it was plus 1, it will become minus 1. So it will go for the second iteration. I will be 2 over here. So sum equal to sum plus. Earlier sum was 1 because 1 square it was, plus minus of CO because it has become minus 1. Okay, sum that is 1 square minus 2 square because I would have become 2. Okay, so this will be carried on and on till the end is reached. Okay, the end could be either positive or negative. So now we will do some kind of a trick over here so that we can present our output in a neat format. We need to generate over here 1 square. Okay, in order to generate 1 square, I have to keep the cursor beside 1 and I have to press Alt 2 5 3. So it becomes 1 square. Okay, Alt 2 5 3. Okay, Alt 2 5 3. You have to hold Alt key in your left forefinger, and 2 5 3 is to be 2 5 3 is to be pressed, and simultaneously the finger should be released. Okay, you have to practice this, and here I need to put plus or minus. Plus or minus is 2 4 1. Alt 2 4 1. Okay, plus or minus n square. Alt 2 5 3. Okay, it will give a neat presentation. Okay, an interactive presentation of our answer driven out or doled out by the computer. You please affirm that this simply works. This simply works. So we'll go to the next problem. Write a program to sum 1 plus 1 plus 2 plus 1 plus 2 plus 3 plus etc. 1 plus 2 plus n. This is a sum of sums. Okay, every term is a sum. Okay, the second term includes 2 terms, the third term includes 3 terms. It's a very, very interesting problem, to say the least, and the last term will go up to n terms. Okay, every term has to generate the sum. Okay, therefore let us tackle it very easily. Okay, we have I declared for as a loop index, n is number of terms. Okay, the number of terms in the last term or number of terms over here. So if n equal to 3, we should get the answer 1 plus 3, 3 plus 1 is 4, 4 plus 6, 10 should be the answer. Therefore we will have 2 accumulators, sum equal to 0. Sum will take care of individual terms of the series and big sum will give the total sum. Okay, right. Okay, now it will be very clear to you as we go down the program. Okay, printf enter the number of terms, the user will enter say 10 or say 4, then I equal to 0, I should have been 1 over here, I equal to 1 and I less than or equal to n, I plus plus, I equal to 1, okay, I less than or equal to n, I plus plus, sum equal to sum plus I, okay, it should be small I, sum equal to sum plus I. So in the first cycle what happens to sum is sum equal to 0 plus 1. So you will get 1. Okay, big sum equal to big sum plus sum. Big sum was 0, set to 0. It is 0 plus 1, whatever sum has given. In the second iteration, what happens? Sum equal to, earlier sum value was 1, 1 plus 2. Okay, it will get us 3. And here what happens is, the earlier value was 1, 1 plus 3. It gives us 4. Anyway, big sum will carry the total answer, while the sum will carry the individual terms. So in order to print out the answer in the same way as that of the problem, we have written like this. Okay, this is not a great deal. Okay, here the answer is poured in the percentage D. Percentage D is a format specifier. Big sum is written over here. Okay, we will go to the next problem. It is write a program to find sum equal to 1 plus 1 by 2 plus 1 by 3 plus 1 by n. Anyway, by the just look at this problem, you will be able to understand that the value of the sum is going to be float, because this is 1 plus 0.5, 1.5 plus 0.33, okay, 1 point, let us say 1.8883, 1.83, like this. Okay, it's a typical float value. Therefore, the programmer should be knowledgeable about the kind of answers, the kind of values that are expected, the kind of outputs that are expected. Okay, it is in the hands of the programmer. Okay, we need 2 variables anyway over here, integer I to run the loop and n to decide the number of terms, and float sum equal to 0. Now sum will become a float kind of a variable, therefore it is declared as a float. Clear screen. Of course, these 3 steps involve housekeeping. Enter the number of terms. This is the question posed to the user. Okay, this is called as a user prompt. I repeat, user prompts at a confusing location or before a scanf will make your program reader friendly and user friendly. It will become typically user friendly. Comments will make your program user friendly, reader friendly. Scanf percentage n, okay, number of terms are taken. I will start from 1 up to nth term. Okay, of course n comes in the denominator, let us not worry about this. I plus plus, sum equal to sum plus, if had I placed 1 over I after the first term, it would have given us 0, because 1 is an integer, I is an integer. Okay, integer division results in truncation. We know this. Okay, it has been told earlier in our previous tutorials. Therefore, we should be very careful over here. Okay, sum plus. Now the entire expression will be turned into float expression, and we will get the realistic answer. Okay, 1 plus half 1 by 3. Okay, this is to get a notion of what exactly the problem is. Therefore, the printf is written in a correct fashion, so that it will give a notion of what exactly the answer is. So find the biggest and smallest and the instance they are entered in the data stream. Okay, the biggest of the entries and smallest of the entries. Okay, the user will be simply entering numbers after numbers. Okay, integer I, how many numbers user is to enter, big, small, these are all. Big will hold the biggest of all, small will hold smallest of all, position of small, the instance at which small appeared in the input stream, and the position of big, the position or the instance at which the biggest number appeared, and number. Okay, this is the number that we read. Okay, how many numbers you need to read? Okay, n. I want to read 10 numbers. Let us say that is the answer. That is the user. That's what user enters over here. 10 means, if n equal to 10 means 10 numbers he wants to pick out biggest and smallest among 10 numbers. It could be 20 also. Enter the first number. Anyway, we have to catch hold of the first number. Okay, the first number is entered. Let us say it is 5. First number is 5. Okay, first number is 5. First number is 5. Big and small equal to 5. So in the initial instance, this 5 will become big and as well as small. Okay, it is assumed. So this is called as a multiple assignment statement. Here is a learning, my dear friends. Big equal to small equal to num. Okay, so now number 5, see the entry that is 5 is assumed to be the biggest or smallest. It's an assumption. It's an assumption. Okay, the true big number and true small number will emanate after the happening of the for loop. And position of the big and position of the small both are equal to 1 because this is the first number that we have let in to the memory. Okay, I equal to 2, therefore the iterative construct should start from 2 because the first number is already available. I equal to 2, I less than or equal to n in order to accommodate all the n numbers, I plus plus. So here the loop indices will only pave the way for repeated execution of the calculations or the comparisons or whatever. They never participate in the calculation process. This is an important idea that we have to get from this particular program. In the earlier instances, we have made use of this I also, the loop index. Okay, depending on the problem, we can effectively make use of these loop indices, or we can make use of these loop indices only for the repetition, only for the repeated execution of the statements. Printf, enter the number %d instance, okay, which is the first instance. The number that comes in the second instance, of course, because it starts from 2. So what I receives is 2. Enter the number in the second instance. So number is entered. As soon as you enter the number, let us say it is 6. The first number was 5. Okay, first number was 5. The second number is 6. Now the number is overwritten by 6. The number no longer remains to be 5. It becomes 6. Therefore, we will make use of this big in order to verify whether the 6 is bigger than this first number, because the first number entered is already last. So if big is less than num, okay, we assumed 5 to be big. Big is less than num. Yes, it is less than num because it is 6. Big will become equal to 6. And position of big equal to I. I is 2. So in the second instance, the number is entered. Okay, that's what. Okay. If on the other hand, if you have entered 4 in the second instance, this if condition will work. If small is greater than num, okay, because small is 5, because small was assumed to be 5 in the beginning itself. Now the second number that we entered is 4, so that this will hold good. Small is definitely greater than num, therefore small will become equal to num. Now what small gets is 4. Like that, after repeated, and this is the second instance. Okay, after repeated execution, okay, after all the numbers are entered, when the entry exhausts, then what we get is here. The largest number is %d, its position is this big and position big. The smallest number is %d, its position is %d, that is small, and position small. We repeatedly executed here, and we did comparison with every other number with the previous number. Okay, here comparison took place. And the essential logic of this program is, whenever we need to pick up the biggest or smallest among a host of numbers, among group of numbers, it is essential to assume the very first number to be big or very first number to be small, and upon comparison iteratively we will get to the real big and the real small. Okay, that is the essence of that particular program. Find the first largest and second largest among the numbers entered in a sequence. Okay, this is a very interesting problem. Okay, so integer I to run the loop, n, the number of numbers that you want to let in order to find out largest among 20, the second largest among 20, something like that. First big, second big, and the number. Number is the number that you are going to enter. Okay, it will take care of the numbers that you are going to enter sequentially. How many numbers you need to check? I need to check 20 numbers, let us say. So n will become 20. Enter the first number, you may enter 6, let us say. Or yeah, you may enter 6. Okay, the first number is 6. Then we will assume first big equal to second big equal to number, multiple assignments. So first big will also get 6, second big will also get 6, and we will go for comparison now. Okay, we'll go for comparison. Read the next number. So it will start from 2, because first one is already taken for comparison. The loop will start from 2. So we know where to start the loop and we know where to end the loop. Therefore, for loop is the candidate. Whenever the programmer knows as to when to start the iterative construct, when to end, then for loop is the candidate. Okay, is the candidate construct. Printf, read the next number. So the earlier number will get erased. Okay, anyway, it is stored in either first big and second big, in both. Okay, C is not missed. We have not erased 6 altogether. It is there in first big as well as second big. If first big is lesser than number, let us say we have entered 7. Okay, we have entered 7. Okay, first big, definitely 6 is lesser than 7. Therefore, first big will become 7 and second big will become 6. So here first big, I repeat, first big will become 7, second big will become 6. Now next number comes. Okay, first big is 7, second big is 6. Now if it is 8, then first big will become 8 and second big will become 7. It is something like this. It goes iteratively. Okay, just crisscrossing, just exchanging. Okay, this is what happens. Okay, finally when you print the answer, here it is. The first big number is first big and the second big number is second big. And you should note how exactly the variables are named. This is called as Hungarian representation of the variable name. Okay, by industry standards. Find a to the power of n. N and a are positive numbers. Okay, now that means 5 to the power of 3 is 5 into 5 into 5. There is an iteration. 5 is to be multiplied 3 times. That is the logic. If 5 to the power of 10, 5 is to be multiplied 10 times. Integer I to run the loop, n the index. Okay, n the index. Okay, I think we have done a mistake over here. Anyway, let me remove this. I think power is enough. Power is the variable that we need to induct. Okay, how many numbers you need to check? N numbers I need to check. It's not the number to check. What is the index? What is the index? I think I must have copied that. Okay, copied and pasted the previous problem without my notice. Okay, sorry. Anyway, so scanf % ampersand n. So this will go. Enter the base number. Okay, base number is A. Base number is A. Base number is A. Okay. what I have to do is now power equal to 1. Power is initialized to 1. So this will start from 1, it will go up to n I plus plus. Then what you have to do here is, okay, and I think you must have guessed, power equal to power into a. Power into a. So a will get multiplied n number of times. In the first cycle, power will carry 1 along with it. It is 1 into a. In the second cycle, a into a. In the third cycle, a into a, like that. Okay. So what we get is a to the power of n is, a to the power of n is, in order to get a to the power n, you have to have alt 252. A to the power of n equal to percentage d power. So what we get is a to the power of n over here. Okay, sorry for this mistake. Anyway it is corrected over only. Okay, it happened nicely because I typed here only readily. List numbers in the range 30 to 150 that are divisible by 7 but not by 5. Okay, range is given, so this is the initial value, this is the final value, therefore for loop is the candidate. There is a repetitive action that is to be done. Every number starting from 30 is to be verified whether it is divisible by 7 or and not by 5. If it is so, if this condition is met, it will be listed, otherwise it need not be listed. And we also want to make a count of such numbers. Okay, how many such numbers will appear between 30 and 150. Integer I to run the loop, count equal to 0 because we don't have initially. This is an accumulator. This variable is called as accumulator for possible accumulation. How many numbers between 30 and 150 are divisible by 7 and not by 5. The numbers that are divisible by 7, not by 5, that are divisible by 7, okay, but not by 5 are, this is to create heading. We cannot put this heading within the for loop because from here till here, so many, that is 150 minus 30, 120, 30 is also included. Therefore, it is 121 times this heading will be printed unnecessarily. So entire screen will become clumsy. Therefore, we need to get headings only one time. Therefore, it is placed above the for loop. So for I equal to 30, okay, we will take this down. Okay, for I equal to 30, the starting point of the range, and I equal to I less than or equal to 150, the upper bound of the range, I plus plus. Every number is to be checked. If I mod 7 equal to 0, okay, if there is no remainder upon division by 7, then it is divisible by 7. And if I mod 5 not equal to 0, it is not divisible by 5. Okay, so the condition is stated over here in the form of if loop. And you also you need to understand where exactly the flower braces are required. Under the control of for loop, there is only one statement, that is if statement. Under if statement, there are two statements. Therefore, we have an if block, and for block has only one statement, that is if statement. If at all you want to have a flower brace, you can have it over here, and you have to have it the counterpart of that. Okay, it will unnecessarily, that will create some kind of a redundant flower braces, and it is said it involves computational time, because the control has to verify which block it has entered, which block it is left. Okay, if I mod 7 equal to 0, no remainder upon division by 7, and some remainder upon division by 5 will meet the condition that is stated over here in the problem. And if it is true, that number will be printed, because it is after all the loop index which is being checked. And here is an example where loop index itself is utilized in our computation effectively and efficiently. So count plus plus, the count value will increase, count was set to 0. So here we will get total number of such numbers. Okay, we could have written furthermore between 50 and 150, 30 and 150 equal to so and so. Now, write a program to generate Fibonacci numbers up to given number of terms and given value of the term. Okay, I will leave it to the user. Okay, given number of terms. Okay, so Fibonacci series will look like this. Of course, it will start from 0, 0, 1, 1, 1, like this, 0, 1, 1 plus 1, 2, 2 plus 1, 3. This is the Fibonacci series, a classical series. Okay, we have Fibonacci 1 equal to 0, Fibonacci 2 equal to 1, and Fibonacci is the next term, okay, that we have declared, and NT is number of terms we want to generate, and I is meant for running the for loop. Okay, it's a loop index or it's a counter in the loop. Clear screen, print a Fibonacci series up to n terms. Okay, so this is printed. Okay, and we can have up to n terms, yeah, up to percentage d terms. We can make it still clear, and we will add over here nt. Okay, n terms. Okay, anyway, still we have not read. This is okay, this will hold good, this is correct. Whatever that we enter the number of terms, we will enter because it has been specially declared. So nt stands for number of terms. Printf, this is to be printed first because this cannot be generated. These are all the initial values. Fibonacci series can only be generated with the initial values 0 and 1. This should be remembered. Okay, so this will be printed because we need to print the complete series starting from 0 and 1, including 0 and 1. Therefore the series will start from 2, the third term actually. It will start from the third term because first 2 terms is already there. Okay, I plus plus. So Fibonacci equal to Fibonacci 1 plus 2. Fibonacci 1 was 0 and Fibonacci 2 was 1. So 1 plus 0 equal to 1. Fibonacci 1 will become 1 and Fibonacci 2 will also become 1. Fibonacci 1 equal to Fibonacci 2 and Fibonacci 2 equal to Fibonacci values, whatever that we got over here, and we will print FIB. Okay, immediately it will print the next term. Okay, you should notice over here. Okay, actually this is to be taken. Okay, print should come over here. Yeah, now the exchange should happen, otherwise it's going to give wrong results. Okay, you have to try. I request the respected viewers to try this upon. Okay, and what happens? Fibonacci 1 plus Fibonacci 2, that is 0 plus 1 in the first cycle, in the third cycle. So it will get us 1 once again. Fibonacci 1 will become Fibonacci 2, Fibonacci 1 will receive 1, Fibonacci 2 will receive 1. The next term will be 1 plus 2, 3. 3 will be printed. Like this, cyclically it happens up to n terms, and it will be printing. Write a program to check whether a given number is prime or not. Okay, in order to, there are two methods actually speaking, there are two methods. One is start dividing the given number from 2 to square root of its own, or now you check it like this. Let us say 13 is a prime number. Okay, you start dividing from 2. Okay, 13 by 2, no, it's not divisible. By 3, no, divisible, it's not divisible. Like this, it's enough if you go up to half of its value. 13 by 2. 13 by 2 is not 6.5, it is 6, because integer division leads to truncation. It's enough if you divide up to half of its own value. If it is divisible anywhere, it is not a prime. If it is not divisible from 2 to 6, okay, 2 to 6, or starting from 2 to half of the number, half of the given number. Okay, if it escapes any division, okay, complete division, okay, then it should be a prime number, otherwise it's not a prime. So to have a counter, to have a check, we have another special variable called as a flag. I think we have noticed one special variable called accumulator in the previous examples, and another one is flag. This flag is used with the same name. So whenever we need to check multiple numbers or multiple operations, then flag is a must. Okay, we will just explain this, we will just elaborate this as to why we needed a special variable called flag. Enter a number to check for the prime property. We entered the number, let us say it is 13. Flag equal to 1. Flag equal to 1 means yes, the given number is prime. It is as good as telling like this. Okay, now we will check over here. For I equal to 2, anyway the number is to be divided, any number is to be divided starting from 2 up to half of its value. Okay, I equal to 2 to half of its value. The number is 13, 13 by 2, I plus plus. If anywhere number mod I equal to 0, 13 mod 2 in the first cycle, 13 mod 3 in the second cycle, mod 4, mod 5, mod 6, nowhere it gets divided. Therefore, the flag remains to be 1. On the other hand, if you had we given, let us say something like 6 or something like 8, okay, then number mod is 8, 8 mod I, 8 mod 2 equal to 0. Then flag would have become 0. So after the finishing of this for loop, the flag will remain to be 1 if at all the given number is prime, or the flag would have become 0. Okay, as soon as flag becomes 0, there is no question of testing it again. Okay, for example, if the number is 9, let us say 9 is not divisible by 2. Okay, 9 mod 2 is not equal to 0. Therefore, once again it will go. So I will bring 3 along with it. Therefore, 9 mod 3 definitely is equal to 0. Then flag will become equal to 0. So in such case, the control should break. I think we should recall the usage of break in switch statement. So break will facilitate the jumping of the control from the block where it appears. So as soon as flag becomes 0, there is no need to go for the next cycle. It will break and the control will come over here. If flag means if flag not equal to 0. Okay, if flag here means, okay, it is a brevity in writing the program. Okay, we are showing a brevity in writing the program. We should write like this only. Okay, if flag means if flag not equal to 0, that is the meaning. Okay, if flag not equal to 0, it's one and the same as telling if flag equal to 1. Okay, if flag equal to 1, the number is prime. Otherwise, if flag has already become 0, then the number is not a prime. Okay, that's how we do this. Okay, you please execute this. Okay, purposefully I have not shown the answers over here. Anyway, they are all tested programs. Okay, I just advise my respected listeners to execute this, or if they are pretty confident in C, they can turn this program in Python, turn these programs in C++ or any other language of their choice, and see whether it is Java. You see whether it is working. This is a very simple testament for the effective use of for loop. Okay, this program is a simple guessing game. Okay, the computer is to generate a random number between 1 to 20. The user is given up to 3 tries to guess the exact number. Okay, computer will guess a number, will generate a random number, and the user will be asked to guess it 3 times, and he will be given hint also. After each guess, the computer will tell the user if the guessed number is greater than the random number, or lesser than the random number, or equal to the random number. If incidentally the user guesses the exact number, what computer presumed or what computer generated randomly, then no more guesses should be made. The program should terminate. If the user has not guessed the number after 3 tries, the number is to be displayed and the program is to be terminated. I think this is a small exercise, and here also we need to use for loop because the user should be given only 3 chances. Okay, starting from the first chance, he or she should be given 3 chances. Therefore, we know where to start the iteration, we know where to end the iteration. Therefore, for loop is the candidate. Since we need to generate random numbers, we need to include std standard library.h and time h, because every time the program is executed, it needs to generate different random number. Therefore, time h is to be included. Let us not debate on this. Anyway, these are to be included. These files are to be included in the header. In the header means in the head of the program, in the beginning of the program. Those files are called as header files. Okay, how a random function should work is written, very well written in stdlibh and also time h. Okay, right. we will go there. Integer guess. Okay, this is the number guessed by the user, and this is the number generated by the computer I to run the loop, to give him or to give her, to give the user 3 chances. Clear screen? Randomize. This function is to be called, and this is defined in time.h. Number equal to random 20. This is called as a seed value. Okay, this is called as seed value. The meaning of this is from 1 to 20 or 0 to 20, sorry, 0 to 20. Randomize will initialize a random function, and this is defined in stdlibh, and this is defined in time.h. Okay, now we are giving a chance. Okay, number has come over here. Let us say it is 6. Let us say it is 6. Now we will continue. I equal to 1, I less than or equal to 3, first cycle, second cycle, third cycle. Fourth cycle it will never go, I plus plus. This is to give 3 chances, that's all. Printf, guessing count, the first time. Guessing count 1, it will come because I is 1. Percentage d guess, this is given by the user. If guess is greater than the number, then you will give a report to him, printf, no, you have guessed more than the number. If the guess is less than the number by the user, no, you have guessed less than the number, else printf, you guessed rightly, then break. If he guesses in the first cycle itself, there is no fun in continuing this again and again. There is no need to give him a chance. Therefore, we will break, the signal will be breaking, the control will be breaking out of the loop, and it will be coming directly over here. Okay, it will print this, you guessed it rightly, and it will come over here. After leaving the block, wherever it appears, the number was indeed, okay, I have to make it small p, sorry. Okay, this care is to be taken because C is case sensitive, my dear friends. C is case sensitive. Printf, the number was indeed percentage d num. Okay, here we are definitely printing, and the user will be taking aback if he or she has guessed wrongly. Then we will say a courtesy thank you. The computer would say courtesy thank you because the user's participation. Get_h is printed as I told you earlier. The answers will wait till you give a character to the system. Okay, get_ch. Guessing count 1, 12. Here is a run which has been taken as a screen snapshot. 12 is entered. No, you have guessed more than the number. Guessing count 2, second time option. He prints 8. No, you have guessed more than the number. Guessing count 3. He prints 6. No, you have guessed less than the number. The number was indeed 7. Thank you. Okay, and we will just go through. We will once again revisit this for loop for scientific programs or programs of engineering interest. This tutorial has given you some kind of an introduction or some kind of standard simple problems, of course, programs that can be written using just for loop, and which is really for loop is the candidate for all the 11 programs that we discussed, or 11 programs that we presented in this module. Okay, now these are all the 5 important points that we have to remember as far as for loops are concerned. For loop provides all necessary looping parameters in a single statement. Okay, in a single statement it's going to give. For loop is a pre-test loop because before the control enters into the looping body, okay, it will be tested over here only. Okay, I is set to 1, it will, is I less than or equal to 3? Yes. So testing will be done before control enters into the block for loop. Therefore, it is a pre-test loop. Break statement is used to terminate the loop prematurely. We have done this over here. Okay, if the first try itself is correct, then you guessed it rightly, it is to be printed and the control is to be broken. It should come here. Because there is no fun in giving him a chance again, because the problem statement doesn't appear that way. Okay, depending on the situation, we need to break. We need to use break. Even the iterative constructs can be stopped. Breaks can be applied even for iterative constructs. Okay, it is wrong to put semicolon after the for loop for statement. If you put a semicolon knowingly or unknowingly, it will execute only one time. and some compilers do not admit even for time. Therefore, for loop will die a natural death. Okay, therefore it is not a prerogative of the programmer to put a semicolon over here, because it doesn't befit the syntax of for loop. When the starting point of the iteration and the ending point of the iteration is known, where to start the iteration and where to end the iteration is known for a given problem, then for loop is an appropriate construct, and it comes in a very handy way, because every statement, every control is written in a single line. Okay, initialization, the test expression, and incrementation or decrementation. So with this we will conclude, and the next session will be on while loop. Till then, bye.